One of the guided practice packet, and we're going to be doing a review of all the stuff that we learned yesterday about quadratics. So first, identifying each property for the graph based on just the graph being given to us. So zeros, remember, are the x-intercepts. Does this graph have x-intercepts? Yep. One at -1 and one at +3. So we say x equals -1 and x equals 3. You could write those as coordinates as well, but this is going to help us later just for consistency once we start solving these algebraically. Now, your y-intercept is where it hits the y-axis. This one I would like you to write as a coordinate, and that coordinate is 0, 3. And now for the axis of symmetry. So this is our first kind of piece of memorization that we have to do in this chapter. The axis of symmetry is an equation for a vertical line. That equation is x equals -b over 2a. So that formula for the axis of symmetry you will want to memorize. So looking at our, actually we don't need to use that for this one, my bad. Our axis of symmetry just cuts the graph in half. We'll use that axis of symmetry later. Our axis of symmetry goes through the vertex point and cuts the graph in half. So we actually can't use this equation here because we don't know the equation of that parabola. So our axis of symmetry equation will be x equals 1. So do make sure that you have the x equals, since this is a vex or vertical line equation. What are the coordinates of our vertex? One, 4. Here's 1, up to 4. That's where our vertex is. For our end behavior is going down and down, so towards -infinity on both sides. So that notation, as x goes towards -infinity, f of x goes towards -infinity. And as x goes towards positive infinity, f of x goes towards -infinity. So -infinity for both because we are going down, down. What's the domain for all quadratics? All real numbers. Or -infinity to positive infinity. And folks, just to clarify, you only need to write one of these. You don't have to write both. But our range, where do our y values start vertex-wise? At 4, and we are covered going down. So y less than or equal to 4, or -infinity to 4 with a bracket. So folks, that's what all of those key features are and how we pull them directly from the graph. Next, we're going to get into the tougher part of this, which is figuring out all of the key features from the equation, which we will have to graph ourselves. So first, folks, how do I know this is a quadratic? It's got our ax squared, our bx, our plus c, so its degree is 2, and it's got all those other parts of standard form for a quadratic. So we can start anywhere with this, except not with the zeros. We can't find those x-intercepts straight away. Can we find our y-intercept? Yeah. What happens when we plug 0 in for those x's? We get -4. So your y-intercept is always equal to your c value, but you can always just plug in 0 into the equation to find that output of -4. Your axis of symmetry, this is where we're going to use that equation, -b over 2a. So let's first look at the equation and see what our a, b, and c values are. So what's my coefficient of x squared? 1. So positive a value means positive leading coefficient. So that means we're going to have a happy quadratic. You don't have to write that. It's just kind of a nice thing to know as far as checking your graph is concerned. What's my b value? -3. That's the coefficient of your x term. And your c value is -4. So for our axis of symmetry, the a of s is negative b over 2a. So my b value is -3. So we'll have -3, which will be a +3, over 2 times my a value of 1. So this gives me 3/2, or as a decimal, which will be a little bit easier for graphing, 1.5. So my axis of symmetry equation, so our axis of symmetry equation will be x equals 1.5. So that's where we're going to draw in our dashed line that will cut our graph in half. So here's 1, here's 2, so 1.5 is about ish. Now, what do we know about the vertex now that we know our axis of symmetry line? 1.5 is the x, perfect. So we don't know how high that vertex is, but we do know that it's probably going to need to be down here somewhere in order to curve up through the y-intercept to make a happy graph. But that x value has to be 1.5. How do we find the corresponding y value? We plug it into our equation. Folks, go ahead and grab calculators off the card if you need one today. So 1.5 to the power of 2. We do not need parentheses because 1.5 is not negative. Arrow over to escape the exponent. -3 times 1.5. And actually it's -3 times 1.5. And then -4. So notice we've got a big minus sign in front of the 3 and a big minus sign in front of the 4. Folks, if you use a little negative here, your calculator is going to end up multiplying all 4 of those terms together. And ew, we get -6.25. So -6.25. So it's rather gross, but we are going to plot that point exactly. So down 6 and then just a titch more. So we want to make sure that we're not going more than halfway between the boxes. So axis of symmetry leads us to the x value of our vertex. And now we can use that to structure our table. And remember, how big does our table need to be? Big enough to catch those zeros or to catch the x-intercept. So it might need only 5 points, it might need 9 points. We won't know until we start plotting those points. So we're going to center this around our vertex. So 1.5 and -6.25. Now, here's the part that sometimes throws students off. How do we go below or to the left of 1.5? Folks, look on your grid. What nice integer is directly to the left of 1.5? 1. And what integer is directly above 1.5? 2. So you don't have to go by decimal increments. I always just go to the next closest integer when my axis of symmetry is a nasty decimal like that. So that's why it's a little bit easier to think of it in decimal form than fraction form for picking those other nice values. Another point below, 0. Another point above, 3. So we're going to start with these 5 points and see where it gets us. Now, do we already know what 0 will give us for an output? -4. It's the y-intercept. Now, what about 1? So 1 squared minus 3 times 1 minus 4 gives us -6. Should we assume that 2 gives us -6? I mean, we should hope so, because that's what's going to verify that our vertex is correct, but always do one test for that symmetry first. Second, enter to copy paste the previous line, and then you can override those ones with 2s. Woohoo, we got -6, that's great. Because now we've got that symmetry there, which means we're also going to have that symmetry here. So let's go ahead and plot those points and see where we're at with finding our zeros or our x-intercepts. Are we going to hit the x-axis? Yup. Have we hit the x-axis yet? No. So we see that we are going to curve up and hit that axis, but we need to go a little bit further down with our table, a little bit further up with the table. Now, folks, to avoid having to use parentheses, which value is easier to plug in, -1 or 4? 4. So I'm going to hit second enter. I'm going to override those 2s with 4s. And we see that we get 0, which means this one is 0 as well. And there they are. We have now found our x-intercepts. So x equals -1 and x equals 4. And now we can swoosh on through those to make our parabola U. Making sure that you put arrows on the ends to show that it goes on forever and ever. On your own, state the end behavior, the domain, and the range for this one. All right, go ahead and check yourself. As x goes towards -infinity, our function is going up towards +infinity. As x goes towards +infinity, our graph is going up towards +infinity. The domain is all real numbers, always all real numbers for quadratics, or -infinity to infinity. Now the range values, my y values start at -6.25 and are covered going up the axis. Something to be careful of, because we encountered this a few times in 4th block yesterday, was remembering that y values come from the y part of your coordinate and not the x value. So I tend to read it directly from the graph and actually trace that y value and see that I am covered going up. So just be careful and make sure you're using the y value and not the x value. All right, folks, any questions on that one? On this next one, take a look at the original equation. If I asked you to state the A, B, and C values, which of those values are we missing?
B.
B, because there's no x term. So that means A is -4, so it's a sad graph because our leading coefficient is negative. So if you wanted to, you could state the end behavior from the get-go. Our B value then is what?
0.
0, because this is like having 0x plus 5. And then 5, that's going to be our C value. With this in mind, I want you to try to find the axis of symmetry, the vertex, and number 3, the table. I'm going to give you a few minutes to try this one. I'm going to start going through that axis of symmetry work. So x equals negative b, so negative 0, over 2 times the a value of negative 4. Folks, what's 0 divided by negative 8? It's 0. So if you're not sure, you can think of dividing $0 amongst a bunch of people. They'd all get $0. Or you can check yourself on your calculator. 0 divided by negative 8 is 0. It's dividing by 0 or trying to divide something into no parts that is not allowed or gives you something that's undefined. So our axis of symmetry is x equals 0. Did you remember the x equals? For the vertical line equation? Love it. So x equals 0. So I'm going to draw in my vertical line at 0. And that means the x part of our vertex is 0 as well. If it lies on that line somewhere, it has to have the same x value. So what happens when we plug 0 in? Hopefully you didn't have to use your calculator. 0 squared is 0. Times negative 4 is 0. 0 plus 5 is 5. And not only have we found our vertex, what else did we find? The y-intercept. So both are at 0, 5. So I'm going to center my table at 0, 5. Couple points below, couple points above. Now, folks, we do have negative values to plug in here. So remember from yesterday, we said that it is vital that we trap those negative values in parentheses when we are plugging them in with our exponent. So I'm going to start with negative 2. We'll have little negative 4 times parentheses little negative 2 squared, arrow over to escape the exponent, and add 5. And we get negative 11. So parentheses. If you are worried about making a mistake with the parentheses on your calculator, you can do it by hand. Negative 2 times negative 2 is positive 4. 4 times negative 4 is negative 16. And negative 16 plus 5 is negative 11. So you either have to be sure you're doing the parentheses right on your calculator or use some mental math and do the operations in your head. So negative 1. Now that I already have those parentheses in there, we can do second enter to copy paste. Override that negative 2 with a negative 1, and we get 1. Now, to plug in 1, I'm going to hit second enter. And if you hover over the negative and use your delete key, that will eliminate the negative sign. And we see that we get 1. So again, folks, until you've done quite a few of these, we don't want to assume that these values are going to be the same, just in case you goof somewhere with your axis of symmetry or you mess something up with the vertex itself. So make sure you're always testing 1 to get that range reflection. So then 2 would give me negative 11. So let's go ahead and plot those points. 5 is enough to get the shape of that U. And let's see where we're at with finding those x-intercepts. Ooh, negative 2, negative 11, just a titch off the graph. Then negative 1, positive 1. Oh, 0, 5, there it is. 1, 1. And then 2, negative 11. Have we crossed the x-axis? Whoosh, whoosh. Don't forget your arrows. We crossed the x-axis. Did we find the x-intercepts exactly? No, because our x-intercepts are supposed to be a number and 0. I don't see any number and 0 on my graph, only 0 and a number for the y-intercept. So we have crossed the axis, and my x-intercepts are somewhere between these values. Most of the time, if you're a pretty decent graph drawer, you can figure it out just based on where your points would be hitting. But we showed on the table yesterday that when we are looking for that 0, we want to see where our y values change from a positive to a negative. So here I go from negative 11 to positive 1. That means somewhere in between that negative and positive y value, we hit a 0. And that means somewhere in between these two x values, we have an x-intercept. Same with down here. Somewhere between this positive and negative value, we get a 0. So somewhere in between those two values, we get an x-intercept. So the appropriate way of stating our answer is x is between -2 and -1, and between 1 and 2. Making sure we're stating the x values for the x-intercepts, but we're looking for a sign change in our y values. What questions do you guys have on that part? Those between ones are the tough ones. And if I look at my graph, does that seem reasonable? Between -1 and -2? Yep. And between 1 and 2, yep, it's close to 1, but we still see that we fall between those two tick marks. What about the end behavior for this one? We look to the left. As x goes towards -infinity, my function plummets down towards -infinity as well. And then as x goes towards infinity, or positive infinity, f of x also goes down towards -infinity. So that's what's kind of nice about these quadratics is the end behavior is always going to go in the same direction. And this is also going to keep us funky fresh for our review for our term test. So keeping that end behavior notation in our brains so that we remember it for the previous unit as well. Our domain is all real numbers. Or -infinity to infinity. And then our range starts at 5 and is covered going down. So y less than or equal to 5 or -infinity to 5 with a bracket. All right, folks, any questions on those ones? Hopefully, we're feeling a little bit better about the graphing than we did yesterday. So we are going to go ahead and start the homework quiz next.